Hi everyone, and welcome back. Our next problem says, give the Lewis structure of CH₃CH₂OCH₂CH₃. So we're given a condensed structure where we see kind of the order in which our atoms are, so we know how they're connected to each other, but we don't know what type of bonds connect them, if there's lone pairs, anything like that. And we need to go to a Lewis structure, which shows bonds, the lone pairs, and formal charges on all of our atoms. So let's think about what our molecule looks like. We have 2 carbons and then an oxygen and then 2 more carbons. So we have an ether here. So we know we have carbon, carbon, oxygen, carbon, carbon, all connected by single bonds. And then we have our, going left to right, our terminal carbon has 3 oxygens. So we'll put them on there. Next one is CH2, so we'll add 2 hydrogens there. Our O doesn't have anything connected to it. Then CH2 has 2 hydrogens. And CH3, put those 3 hydrogens on there. So now we have how everything will go together. We need to look at how many valence electrons overall do we have, and does our structure fit this? So total valence electrons. So we have 1, 2, 3, 4 carbons. So it'd be 4 carbons multiplied by 4 valence electrons. Plus we have 3 plus 2 is 5, plus 2 is 7, plus 3 is 10. 10 hydrogens. So 10 hydrogens multiplied by 1 valence electron. And then we have our 1 oxygen. That would be 6 valence electrons for that. So we'd have 4 multiplied by 4 is 16, plus 10, plus 6 equals 32 total valence electrons. So let's look at our structure and count up the bonds that we have here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So total valence electrons. We have 14 bonds multiplied by 2, which would equal 28. So we know we're missing 2 as this is drawn, or missing 4, excuse me, 4 electrons as this is drawn. So let's look at where those missing electrons might go. Who has a completed octet and who doesn't here? Well, the hydrogens all have their single bond, so they've got all the electrons they need. Our carbons, each of them has 4 bonds. So for carbon, we've got 4 bonds multiplied by 2 electrons equals 8 electrons. So they've got a complete octet. But our oxygen only has 2 bonds. So 2 bonds multiplied by 2 electrons equals 4 electrons. So our oxygen must have 2 lone pairs, since there are 4 more electrons. Well, there's the missing 4 electrons that we need. So put 2 lone pairs on our oxygen. And now the only thing left is to check if we need to add a formal charge anywhere. So for a carbon, hydrogens, all of them are single bonds. So hydrogen, of course, has 1 valence electron, 1 bond, 1 minus 1 is 0. So our hydrogens as drawn will have a formal charge of 0. Carbon, formal charge would equal the number of valence electrons, which is 4, minus the number of non-bonding electrons, which is 0, minus the number of bonds, which is 4, which equals 0. So no formal charge. In this case, the oxygen, its formal charge, we would have the number of valence electrons is 6, minus, we have 2 lone pairs, so 4 non-bonding electrons, minus 2 bonds. 6 minus 4 minus 2 is 0. So the oxygen has no formal charge. So none of these atoms here has a formal charge, so we're done with our Lewis structure. Just highlight that. We've got all our carbons with their accompanying hydrogens. We know how this is connected to form ether. And our oxygen has 2 lone pairs added to it in the structure. See you in the next video.